In this video, we're going to start the KutaSoftware Infinite Geometry free worksheet, coordinate geometry, and the centroid. Now remember, the centroid is the point at which the medians of a triangle intersect. So all three medians will intersect at this one point, which is the centroid of a triangle. So our directions are to find the coordinates of the centroid of each triangle. In number 1, we're going to start by drawing our medians. So the midpoint between side xz is going to occur at 1.5, since the distance from z to x is 1, 2, 3. So 3 divided by 2 is 1.5, and that will get connected to the opposite vertex. So there is one median. Our next median, let's use this other line going from y to z. That way we can just count. So it's 1, 2, 3, 4, 5, 6. So from y to z, the distance is 6. So 3 will be our midpoint, and that occurs at -3, 0. So now we'll draw our other median. And since the centroid is where the medians intersect, we need only two medians to see that the intersection will occur at this point, and that point is -2, 1. So our centroid occurs at -2, 1 for number 1. And number 2, we'll start by locating the midpoint between D and F. The distance between those two is 1, 2, 3, 4, 5, 6, 7 units. So the midpoint will occur at 3.5, since that's halfway between. So 1, 2, 3.5. So at -1.5, 0 is where the midpoint occurs. -1.5 in the x and 0 in the y. So now we'll draw our first median from the opposite vertex E to our midpoint, -1.5, 0. Now we're going to find the midpoint of D and E. However, this is no longer a horizontal or vertical line to where we can just count, so we're going to have to use the midpoint formula. Remember, the midpoint formula is m equals, and then our first coordinate is x1 plus x2 all over 2, and our second coordinate for the midpoint is y1 plus y2 all over 2. And if you're confused on this formula, you can go to my geometry tutorial section on YouTube where I go more in depth, or if you just need practice, go to the video within my KutaSoftware geometry playlist on the midpoint formula where I work through the practice problems. So we need x1, x2, y1, and y2 in order to solve for the midpoint. D occurs at -5, 0, and E occurs at 0, 6. So we have x1, y1, and x2, y2. So our midpoint, M, will equal -5 plus 0 all over 2, comma, 0 plus 6 all over 2. So the midpoint will equal -5 halves and 6 over 2, which we can write as -5 halves, or -2.5. 6 divided by 2 is 3. So our midpoint occurs at -2.5, 3. And now we'll draw a line from our midpoint to the opposite vertex, creating another median. And you can see that the medians intersect at point -1, 2. So -1, 2 is our solution in number 2. In number 3, let's start with finding the easiest midpoint. You can see that R to P is a horizontal line, so we will be able to count. The units between R and P is 1, 2, 3, 4, 5, 6. So the midpoint will be 3 units away from R, which occurs at -3, 6. So then we'll draw our line for our median, going from Q to that midpoint. Next, we'll calculate the midpoint of, let's do from Q to P. Q occurs at -3, 0, and P occurs at 0, 6. So in the midpoint formula, our midpoint M is going to equal x1. So let's make x1 -3, and x2 is going to be 0. y1 will be 0, and y2 will be 6. So -3 plus 0 over 2, comma, 0 plus 6 over 2. So our midpoint M is equal to -3 halves and 6 halves. So we can say -1.5 if we want to write it as a mixed fraction, and then 6 divided by 2 is 3. So at -1.5, 3 occurs the midpoint between Q and P. So now let's draw our median from the vertex R to the point -1.5, 3. And you can see that those two intersect at -3, +4. So our centroid is -3, 4 in number 3. Moving on to number 4, again, we're going to start with calculating the easiest midpoint, and that's between L and K since it's a horizontal line. The units between them equal 1, 2, 3, 4, 5, 6, 7. So 7 divided by 2 is 3.5. So the midpoint occurs 3.5 units away from L and K. 1, 2, 3.5. So this midpoint occurs at 1.5, 0. So now drawing our median from the vertex that's opposite the midpoint to the midpoint. Now let's calculate one other midpoint, draw the median, and then see where that centroid lies. Let's calculate the midpoint between L and M. L occurs at -2, 0. So let's make this x1, y1, and M occurs at 0, -6. So this will be x2, y2. Our midpoint M equals x1 plus x2, -2 plus 0, all over 2, and y1 plus y2, 0 plus -6, all over 2. So our midpoint M occurs at -2 over 2 and -6 over 2. So midpoint is equal to -1, -3. So we're going -1, -3, and plotting our midpoint. Now we're going to draw our median from the opposite vertex, which is K, to our midpoint of LM, -1, 3. And you can see that where those medians intersect is this point, +1 in the X, -2 in the Y. So 1, -2 is the coordinate of the centroid for number 4. And the last problem I'm going to do in this video is actually going to be number 16. So scrolling down to number 16, it's a critical thinking question and it refers back to number 1. It says, for question number 1, connect the midpoints of each side of the triangle to form a smaller triangle within the original triangle. So let's do that step and then we'll come back. So we're finding the midpoints to form a smaller triangle. Back up to number 1. We already have the midpoints of 2 separate sides, so let's find the midpoint of yx. Y occurs at -6, 0, and x occurs at 0, 3. So the midpoint, M, is going to equal x1, y1, -6 plus 0 over 2, comma, y1, y2, which will be 0 plus 3 over 2. That's equal to -6 over 2, comma, 3 over 2. So that will be -3 and 1.5. So -3, 1.5, plotting that. Now we're to connect the midpoints to form a smaller triangle. So now that we've drawn our smaller triangle, let's see what question 16 asks. So now that we used the midpoints of each side of the triangle to form a smaller triangle within the original triangle, we have to find the coordinates of the centroid of the smaller triangle. And then it asks what happened and why. So we're locating the centroid of our new triangle. Let's call this triangle A, B, C. So the midpoint between A and C, we know this distance is 1.5. So we're going to go up 3/4. If we were to draw that median, it follows the previous median that we already had. Now let's find the midpoint of A to B. The distance between A and B, since this is a horizontal line, is 3 units. So the midpoint occurs 1.5 units away from A and 1.5 away from B. This also falls on a median, and when we draw the line that makes the new median, it follows the same path as the old. So you can see that the centroid is the same. The centroid is again -2, 1. So back down to number 16, it says what happened and why, and we can say that the centroid stayed the same. And why is that? Well, if you notice, the medians didn't change. So the centroid was the same because the medians did not change. and where the medians intersect is where that centroid lies. So if the medians don't change, they're still going to intersect at the same point. And with that, we'll wrap up this video. Join me in the next video where I'll go over problems 5 through 8, showing you 2 new methods to find the centroid.